Okay, we begin the unit on rational expressions. This is the standard. It says understand that rational expressions, meaning algebraic fractions, that's what that is, form a system analogous to the rational numbers, meaning they form a system just like fractions, that's rational numbers, and it's closed under addition, subtraction, multiplication, and division by a non-zero rational expression. So here's what we're doing. Here, get to the nitty-gritty at the end. We're adding, subtracting, multiplying, and dividing rational expressions. Now, before you can add, subtract, multiply, and divide rational expressions, you must know how to simplify them. So we are going to simplify just a regular rational expression before we add, subtract, multiply, and divide. All right, from elementary school, my dears. Elementary, my dears, elementary. Okay, remember in elementary school when you did 4/6 and you simplified it to be 2/3. They're equal, but you take out a common factor of 2. Same thing. This is the simplest form. It has no factoring. We just want to simplify our numbers like we always have all the way in elementary school, middle school, everywhere else. 6/12 has been 1/2 for years. It still is. And when we simplify with our variables out of that unit that we did on exponents, remember, if you have one of them over one variable over another, you just subtract their exponents and you put your leftovers where the largest exponent is. And in this case, the largest exponent is in the denominator. So 4 minus 2 means that there are 2 left in the denominator. All right, let's move to some more complex ones. Here are our steps. When you are simplifying rational expressions, you want to factor your numerator, and we all know what factoring is. We had a whole unit on factoring. We want to factor our denominator. We want to cancel out what's the same or simplify, and then write down whatever is left. Okay, so I take my numerator. I don't look at my denominator. I only look at my numerator, and I can take a y out of y squared and 7y. You see I'm saying it. Y squared plus 7y. They both have a y. You factor out y, and you're left with y plus 7. If I take this and divide by y, I have y plus 7 left. I do the same with my denominator. Now I'm going to factor my denominator. I'm going to take 9 out. That's going to leave me with y plus 7, and the y plus 7's cancel out. Now look what I wrote down here. Oh, and your final answer is y/9. Look what I wrote down here. You must be able to cancel the entire parentheses. You must. You cannot cancel like this. Y plus 14 over y plus 7. When there's a plus sign, you can't do this. That's not true. That's not going to give me 2. That's just an untrue statement. That's like saying, let's say y has a value of 2. If I do 2 plus 7, or no, 2 plus 14, over 2 plus 7, that's going to be 16 over 9, and that's not equal to 2. So that is not true. That's why you have to be able to cancel the entire parentheses.
Don't forget about the lunch pickup today for your students.
Okay.
They'll be set up between the buildings from 12 to 1. and
Sorry
4 to
for the
5
announcement.
today. Thank you.
All right, same thing. We're going to factor our numerator, factor our denominator, write and cancel out what we can, write down the leftovers. This, using the x method, remember you put 6 in the numerator, or the top of the x, 5 in the denominator. What factors of 6 add to be 5? Well, that's 2 and 3. So you have x plus 3, x plus 2. Same thing here, you put -12 in the top of the x, -1 in the bottom. What factors of 12 subtract to be 1? That's going to be 4 and 3, and the 4 has to be negative. That's how -4 plus 3 is -1, and when you multiply them, you get -12. Now, what is the same is the x plus 3, that goes, and my answer is x plus 2 over x minus 4. And no, you cannot cancel the x's, and you cannot cancel the 2 with the 4. Remember on the problem prior, how I explained that can't be done. All right, this one, go ahead and factor the numerator. That's x plus 3, x plus 7. That's the factors of 21 that add to be 10. The factors of 24 that subtract to be 5 are 8 and 3. The 8 has to be negative to get negative 5. So x minus 8, x plus 3. The x plus 3's cancel, and this is your answer. On this one, sometimes you can go through the motions of factoring everything, and we're going to factor our numerator. Remember, this is the difference of 2 squares. So it factors to be x plus 3, x minus 3. Going to take a GCF out here. Oops. And I just see a mistake. The x, take the x out, that's x squared minus 9. This one becomes x plus 3, x minus 3, over x times x plus 3, x minus 3. Those cancel. You end up with 1 over x. That is not x. You have, when you cancel these, there's 1 left over. Just like 3 over 3 is 1. It's the same sort of thing. So you have 1 as a placeholder. You can look at it like that in the numerator. All right, this one, same thing, difference of 2 squares. 4 plus x, 4 minus x. This is a trinomial, so you're looking for factors of 16 that add to be 8. That's 4 and 4, and they're both minus. Now, when you do this one, the difference here is when I cancel these, they're exactly opposite. Positive 4, negative 4. Negative x, positive x. That means when I cancel, I do not have 1 left over, I have negative 1 left over. Just like here, negative 3 over 3, they're opposites. That's not 1, that's negative 1. It's the same reason. And then I wrote down here, 4 minus x is equal to negative 1 times x minus 4. When you factor out a negative sign, that changes the x to positive and the 4 to negative, and therefore now you can see why there's negative 1 left. So this is x plus 4, negative x plus 4 over x minus 4. That's your answer. Or they may write this as negative x minus 4 over x minus 4. They may take that and distribute it. So either of those answers are good. Thank you.